Hello all, very good morning. Thanks for joining the session. Let me share my screen in a moment of time. Yesterday, we have seen the microservices evolution history, and also we have seen the divide and conquer policy, and we even have concluded that by applying the certain principles and characteristics on the divide and then conquer policy, the microservices were derived. So that is what we were discussed yesterday, right? And also we have seen how the modules are being made as a separate applications using the divide and then conquer policy, right? And today we will discuss about the microservices principles and then the characteristics. Very important. Microservices principles and characteristics are very important, very important. So please carefully focus. However, However, before understanding the microservices principles, let us first understand the concept of microservices with the honeycomb analogy. Of course, we have seen yesterday, microservices are tiny applications, small applications, meaning the modules of a huge application will be taken out from the application as a separate tiny application, which will be self-executable, independently deployable, and autonomous. So this is what we have seen. But let us try to understand the microservices with the honeycomb analogy. So this is a honeycomb. Probably we might have all seen the honeycombs, right? So this is a honeycomb. In real world, bees build a honeycomb by aligning hexagonal wax cells. So this each and every hexagonal wax cell will be aligned as a honeycomb. So they start small using different materials to build the cells. Please focus. Each and every word is important in the honeycomb analogy. See here, first of all, using small wax hexagonal wax cells, a complex fabric honeycomb structure has been created. Point number one. Point number two, the hexagonal wax cells are small. Such hexagonal wax cells are used many to construct this honeycomb, and each and every hexagonal wax cell may or may not be constructed using the same material. Maybe this is constructed using the wires, is constructed using the grass, is constructed using the stones. Whatever is available at that moment for the honeybees, those bees will collect that material, and with that material, they will construct the wax cell. Construction is based on what is available at the time of building. They don't stick to only one material like how the human beings will build the houses. No. Honeybees will construct the houses or the hexagonal wax cells with any kind of material, which is available at that moment. So repetitive cells form a pattern and result in a strong fabric structure. So each cell in the honeycomb is independent but also integrated with other cells, right? This cell constructed independently by a set of honeybees, and this cell constructed by another set of honeybees, this cell constructed by another set of honeybees. Likewise, the honeybees were constructed independently but able to communicate with other wax cells as well. So what did you understand here in this honeycomb analogy? Number one, small hexagonal wax cells, nothing but our microservices. Number two, as the small hexagonal wax cells were built using the different material, that is called polyglot architecture. Similarly, as each and every hexagonal wax cell considered as one microservice, microservices also can be built using the different technology, different programming languages. Right now, each cell is independent but communicate with others. Similarly, each microservices is independently executable but able to integrate with the other microservices. So small microservices when integrated together will become a huge application. This is called the honeycomb analogy. So by adding new cells, the honeycomb grows organically to a big. Yes. So if the honeybees will add more cells here, honeycomb will grow more. The content inside the each cell is abstracted and not visible outside. What that mean, this cell can't access the content of this cell. No, they can't access because they independently frame it together, isn't it? When you see the honeycomb, one small wax cell is not able to access the another wax cells. No, that is not possible. Right? So the content inside the each wax cell is not visible to another wax cell. Similarly, the content implementation of the microservices should not be visible to another microservice. What microservice is providing is should be visible. What microservice providing should be visible, but how it is implemented should not be visible. We see this is what the honeycomb, right? So each cell in this honeycomb, this is perfect fabric structure. See this hexagonal wax cells. So the content of this hexagonal wax cell 100% hidden and then invisible to this one. There is no chance of getting this hexagonal wax cell content by this hexagonal wax cell. No, right? Similarly, our microservices also, the content of one microservice should not be visible to another microservice. Content of microservices meaning the implementation of the microservices. How I have written is not required to another microservice. What another microservice required is just a data from my service. So damage to one cell does not damage other cells. Damage to one cell does not damage the other cells. It is a complete fabric structure, right? So when we hit with a stone, the particular part when the stone has been hit might be get damaged, but other wax cell will work as expected. Similarly, in our microservices architecture also, there will be a issue occur only the particular services which got the issue won't work, but other services will work as expected, right? So damage to the cell does not damage the other cell, and bees can reconstruct these damaged cells without impacting all over overall honeycomb. Similarly, when a issue will come, we can go to a particular microservice and then fix the issue there. Due to the issue raised in one particular microservice, the other microservices should not fail. They won't fail even, right? So this is what the honeycomb analogy, and with the honeycomb analogy, we can easily understand. Again, I will repeat here, like how the honeybees group of honeybees one group of honeybee will construct one independent honeybee, or a group of honeybees will construct the hexagonal wax cell. Here one honeybee or group of honeybees nothing but a one developer or a group of developers constructing a wax cell, nothing but writing a microservice. Now wax cells were built using the different material. Similarly, microservices also will be built using the different technology. And next, uh, all the wax cells when integrated will form a fabric structure. Similarly, all the microservices when integrated together becomes a huge application. Next, each cell in the honeycomb analogy, each cell in the honeycomb analogy is independent but integrated with other cells. Similarly, microservices also independently executable on their own Tomcat, but can be integrated to other services as well. Next, in honeycomb, if a particular wax cell will be damaged, then the damage won't, there will be no impact on the other cells around it. Similarly, when a microservices is damaged, there will be no impact on the other microservices. Maybe the functionality of it might not be work, but other microservices won't get affected. And we can easily apply the repair to the damaged microservice only without impacting the other microservices. So this is what the honeycomb analogy. Are you clear with the honeycomb analogy, or any questions in this honeycomb analogy? Any questions for me here in this honeycomb analogy? Okay, great.
Sir,
No
one question.
questions.
Hello, sir.
If sir, one service in like the whole is not connected with nothing to do with other service, how they are not connected with any way, or how exactly means they are completely segregated, or they are connected with some APIs.
APIs, network calls. This API will make a call to this API over the network. So this might be exposed as one complete service, right? So that service APIs will be called by the another services.
So
Got
there
it,
will be controller in all the microservices, right? To connect with.
Correct.
Yeah.
Correct. Yeah. Any other questions? Any more questions? Okay, great. Now let us go to the principles of microservices. We'll examine some of the principles of the microservices architecture. These principles are the must-have principles when designing and then developing the microservices. Must have. What I will do is, let me close this one. So I will try to open our IDE just in case. Just let me open the IDE in a moment of time before going to this solid principles, or before going to the microservices principles discussion. Let me open the IDE and then go back and then start the discussion, because if anything is required, I can code it. However, now see, principles of microservices. Principles are must have, meaning we must have to follow the principles. So microservices principles are must be followed. If you are writing a microservice, you have to must follow these principles. Then only your service is said to be a microservice. Otherwise, no. So what is the principle number one? Principle number one is single responsibility per service. That means what? Each and every microservice should have to represent only one functionality, one single responsibility, one functionality. It should not represent the many functionalities or many goals. For example, if you can see the use application like monolithic application. This is our monolithic application, which contains all the modules inside in it, right? So this is called as multi-responsibility application. Multi-responsibility. Why? Because it have the orders, it have the customers, it have the authentication, it have the home. So this is a multi-responsibility application. But microservices should be single responsibility. That means if the customers is there, that means customer should only focus on the customers related data exposing. Only focus on the customer related data exposing. But customer don't have the any any of the classes, any of the interfaces, any of the database or anything about the orders inside the customer's microservice. So customer microservice, when we build a customer microservice, should have only the customer bean, customer controller, customer commons, customer commons, customer model, customer repository, customer service. That's it. And it should have to expose only the customer related activities like add customer, delete customer, view customer, update customer, get all customer, search customer by the page nation. Only the customer functionality only should have to be exposed through the customer's microservice. Then only we can say the customers is a single responsibility service. We have to design the microservices in such a way that each and every microservice should contains only a single responsibility. So this single responsibility per service is derived from the solid principles. This is derived from the solid principles. You got the point, right? Each and every microservice should be a single responsibility services. It should not hold multiple responsibilities. If that is the case, I will write few things. Just let me know whether it is a single responsibility service or not. If you understand properly, let me write something now. Just let me know whether that is a single responsibility service or not. Yes, I am opening my notepad. Let it, yes, it opened. Now, let me take a new pad. Yes, this is the new pad. One moment. Yes, this is the new pad. Now tell me, customer service. Now tell me, customer management, customer management, authentication management. Here the user registration, meaning authenticating user creates and generating a token. Authentication management, order management. That means creating a order copy for each and every product that is ordered. Next, product. A product can be of one or more categories type. A customer can place an order for purchasing product. Now tell me how many single responsibility services we can derive from the above theory. Tell me how many single responsibilities are there, or how do we made them as a single responsible? Tell me. Customer customer is one single responsibility service. Now authentication, and then what is single responsibility services we can make? Authentication, generate token is part of authentication. It's a small thing. What is their order management, then product management, and then order management, categories management, then payment management, then delivery management. Correct. So these are all the microservices, single responsibility services we can derive from the above theory, where each and every service that we have taken will do exactly one responsibility, single responsibility. Each and every service will do one responsibility, that is single responsibility per service, isn't it? Right? So this is what the single responsibility offers discounts. Correct. Those are also can be considered as a single responsibility services. Right. Now, one moment. One moment. These are all called single responsibility services. Now, how this single responsibility service has been derived? So single responsibility per service is derived from the one of the principle of the solid. So single responsibility per service is a one of the principle of the solid design principle. Solid design principle. So what is this solid design principle is talking about? So solid, yes means the single responsibility principle. O means the open closed principle. L means the Lisco substitution principle. I means the interface segregation principles. D means the dependency inversion principle. Right? So solid meaning single responsibility principle, open closed principle, Lisco substitution principle, interface segregation principle, and the dependency inversion principle. Now let us study each and every principle. What is the meaning of it? So what is single responsibility per services? Right. So the single responsibility per services might you already know. A class should have a single responsibility. This is what we know. We even have discussed now. Now that means what, a class can have only single responsibility. And that means what, uh, yes, that means what, a single class, for example, a single class, we Shopify the controller, a single class which should not contains all these logics inside it. No, this is wrong. Rather, these logics should have to be converted into each and every service. Each and every service or each and every class will have only a particular focused business functionality. right? That is called the single responsibility. Now, open closed principles. So in this solid, O for what? Open closed principle. This is very important principle. Carefully observe. This is very important principles. So classes should be open for extension and closed for modification. Closed for modification. That means what? Assume you have taken a class, written 20 methods inside it, right? 20 methods inside it. Now we want to add, according to the good design, let's say 10 methods we were added, but we want to add the more methods. This is class A. We want to add more methods. So rather adding the more methods like 10 plus 1, 10 plus 2, 10 plus 3, rather than adding the more methods in the A class, let us create a B class which extends the A class, and there we will write the 10 plus 1 and then 10 plus 2 and then 10 plus 3 methods, right? So this will improve what actually? The readability. 100% this will improve the readability, isn't it? So, and also we should not change the current behavior of the class. Maybe we were concluded that the class A should have to contains only 10 methods. After 6 months, we need to add 5 more methods inside the class A. Don't touch the class A because it is fixed. Don't modify the class A. Rather extend the class A, create class B, write the new methods inside the class B. This is what the open closed principle is talking about. So close the modifications, but open it for the extension, right? So that is called the open closed principles. Now tell me, interface is suitable for this or abstract class is suitable for this open closed principle? Which one is suitable? Interface or abstract class or a normal concrete classes with the inheritance? Which one is suitable for the open closed principle? Any idea? Interface or abstract class, or interface or abstract class, or the concrete classes? How interfaces are suitable for open closed principle? Yeah, classes, concrete classes. Concrete classes are suitable for the open closed principle. Interfaces doesn't have any implementations. Na? Of course, an interface with the concrete class is also valid answer, but the answer is concrete classes.
Concrete classes meaning normal.
Normal classes, correct. Normal classes. So are you clear with the open closed principle? Any questions here in the open closed principle? Are we clear? Yes, if you are.
Sir, how to identify that single responsibility thing?
Based on the business functionality. Based on the business functionality. And also to identify the single responsibility services, we need to do a domain-driven design. And there is a domain-driven design, DDD, and there is a bounded context. So using these two concepts, we will apply the single responsibilities. So those things we'll discuss in the next sessions. Your question is 100% valid. How we can define a boundary for this functionality? Like, this functionality is still here only, and this is fixed, and this is single independent functionality. How we can decide? So to do that, we will do the domain-driven design analysis with the bounded context. With that one, we can identify the single responsibility services or single responsibility functionality we can identify. Got it? Okay. Is solid is clear? Meaning is the O is clear? Open close principle is clear? If it is clear, then next principle is what?
Sir, can you give some real example where we use this open closure principle?
Real example meaning in real time only we will write like this. Na? In real time, a class should not contain hundreds of methods, isn't it?
Yes.
We will do what actually? If there will be more methods required, then we will take a new class and then extend it from the class A and then write the new methods in that class A, class B.
Yes, that's true.
Correct.
A real-time example will be customer's address for hello. For example, first 6 months we decide the customer should be residential, and after 6 months we decided that the customer should be corporate. So we can extend residential class to corporate one. This will be the
Correct. Both the addresses will be there, but later in time, after 6 months, when the customer updated his residential address, that will be going to a new class, which is extending the A class. That means the old address is there and the new address is also there. Both are there.
Okay.
Yeah, correct. Good idea. This is one of the realistic. So now let us see the Lisco substitution principles. In the next, S is completed, O is completed. Now let us see the L. So Lisco substitution principle. So what is this Lisco substitution principles? If class B is a subtype of class A, right? Then the object of class A in a program may be replaced with the objects of the class B without altering, right? Without altering any program changes, without altering any program, without any changes to the program, or without any changes to the program A, without doing any changes to the class B or class A. You got this point? Class A is there. Class A is there, which is extending by the class B. Now what we can do, class A having the 10 methods, class B additionally added 3 methods. So class B will have the 10 plus 3 methods inside its total 13 methods will be. So what we can do, wherever we are calling class A, that means A is equal to new A and A dot method 1. So here in this place exactly, we also can do B is equal to new B dot method 1. We also can do this. Correct, right? Without doing any changes to the class A or class B, the objects of the class A can be replaced with the objects of its extension, that is the class B. Is it clear? Any questions here in this?
You mean to say B is extended from a A, and we can create an independent instance for a B.
And
So
then call the methods of A as well.
Yes.
Correct. So that is called Lisco substitution principle. So we are substituting the superclass object in the place of the it with the subclasses objects. Now what will happen? What is the benefit of it basically? Lisco substitution. The benefit of it is, the superclass is completely abstracted, hidden basically. Right? No exposure of the superclass. Only the child class will be exposed to it. So this will enforces the consistency. The parent class or child class can be used in same way without any errors. But of course, when we use the parent class, the method 11, method 12 might not be available. But when we use this approach, method A to method 13, total, all the methods will be available. This is called Lisco substitution principles. For example, just an example, customer have the address A. Now what the customer did, customer want to update address B. Now what will happen? Wherever the address A is used, in place of it, now address B will be used, isn't it? Address A, meaning the address A, address B, both will be there, but wherever the address A is there, now address B will be replaced it. So which will be indicating both permanent address and then the current address. Is this clear? Any questions in this Lisco substitution principle? Any questions here? Are we clear with this one? Yes. If we are clear, let us go to the next principle. That is in solid SO, Lisco substitution interface segregation principle. Let us go to interface segregation principle. Interface segregation. Interface segregation principle. What is this interface segregation principle is talking about? So clients should not be forced to depend on methods that they do not use. What does it mean? What does it mean? What does it mean is carefully observe interface segregation. So we need to, this is wrong, interface segregation. Interface segregation, this is correct. What does it mean basically? So how the interfaces will be segregated? So for example, we have the one interface, right? We have one interface, and that interface having the methods. What now we will do in those methods? For example, interface is having 5 methods, but implementation we have only 3 methods. Just carefully observe my point. Interface segregation. Interface having the 5 methods. Implementation, we have only 3 methods. 2 methods were not implemented. Now, usually for example, anyone who is taking this interface, what they will do? They will do like this, right? Interface A is equal to new implementation class. Correct? Isn't it? Now the interface reference will hold the implementation class object of it, so that we can change any of the implementation at runtime using the strategy pattern. If you follow this, This is called as a strategy pattern. So in the interface reference, you can replace any of the objects at runtime. But if you take only the implementation A is equal to new implementation class, only one implementation will be available. But if the implementation will be taken into the interface reference, then any of the implementations of this interface can be substituted here runtime. That is the benefit of this approach. But however, what is interface segregation? Carefully observe. Now, A dot method 1 is also possible, which have the implementation. A dot method 2. A dot method 2 also possible because implementation is there. It's making sense to call A dot method 3 also good. But A dot method 4 don't have the implementation, and A dot method 5 don't have the implementation. So as the implementation is not available here, right? Any solution that you can provide, how best you can design this? Any solution that you can provide, how best you can design this? Because only 3 are used, 2 are not used. Then what you can do? Any thought?
So we can only add only 3 methods to interface rather than adding all these 5 methods.
Then what about these 2 methods? What about these 2 methods? Maybe later in time implementation might come, right?
Yeah.
So
we create another interface for this.
Exactly, correct. So create another interface. Create another interface and then add method 4 and then method 5. Method 4, method 5. Create interface 2. Extends the interface 1. Perfect. Now what will happen? The interface, when it extends the interface 1, it will have the method 4, method 5, method 1, method 2, method 3. And, oh, sorry. Now remove this method 4, method 5. Yeah.
1 second over here. See, as you said that line number 46. As you said that in the implementation class, we have implemented only 3 methods. Method 1, method 2, and method 3.
Correct.
So the 2 method is remaining. So sir, how we can create an implemented class, because this class is abstract, correct? So and we can't able to create the implementation class object.
No, what I mean to say is implementation class will implement this interface. Na? For example, this is the implementation class, isn't it? So implementation class implementation implements interface, right? So as this implementation class is implementing the interface, into the interface reference, we can create and then store the object of the implementation class.
Yes, sir, but over here we have implemented only 3 methods. Remaining 2 methods are abstract. So this class should be abstract. So abstract class we cannot create an object, correct?
Tell me one thing, actually. That is true. Whatever you are saying is true. Here, what we are talking about, are we talking about making it as an abstract? No. We are talking, that is the problem, not to make it as an abstract. What we will do is the unimplemented methods, let's put into a separate interface.
Okay.
Now what will happen? Implementation class will have the implementation for only 3 methods. So let us not make this as an abstract. So making a concrete class an abstract class will lead to some other issues like object creation, memory allocations, and all, isn't it? So the ideal solution is cut these 2 methods, put into this interface 2. Now implementation class having the implementation for only these 3 methods. Whatever the unimplemented methods are there, right? Those are not in the interface A. So here, no unimplemented methods. Now interface B will have those unimplemented methods, method 4 and then method 5, along with the interface implemented methods as well, or along with interface methods like method A, method 2, method 3 also. This got it? What I'm trying to explain?
Yes, sir. Yes, sir.
Yeah. So this is called what actually? Interface segregation principle. Interface segregation principle. So whatever the unused methods
We can extend. We can extend all the interface. Can we extend only methods? Some methods of interface. We'll have to completely extend interface.
if I understood correctly, if we want the method 4 and then method 5, we want to implement this
Yes.
interface.
So if we extend interface 1 and interface 2, then interface 2 will have all the 5 methods, right? 3 of interface 1 and 2 of its own.
Correct. But that is not possible. In Java, we cannot implement, we cannot extend more than one interface, one class, isn't it? We can implement more than one class interface, but we cannot extend. So that is the reason interface 2 having the method 4, method 5, when it is extending the interface 1, then all these 3 methods plus the 2 extra methods will come. In future, if any of the classes would like to provide the implementation for method 2 and method 4 and method 3, otherwise we can also do like this. Let us create a interface 2 only with the new methods. In the future, if anyone want to implement only method 4 and then method 5, they will go for this interface 2. So best example is what you know, customer is an interface, right? Interface. So far, what the methods we have? Save customer, and then the save customer, and then the update address. Update address. Here only we have update address. Save residence address, and save office address, right? So maybe the customer right now don't have the residence address, office address updated, or maybe only residence address is updated, but an update address is not there, or maybe save residence address, same office address. So now what we can do, we can create one more interface called address. Interface called address. Let us add these 2 methods in the address, right? Now customer will have only the save customer. In future, if any other want to implement this save address, save office address, they can directly implement it from the address actually, right? If we want to implement the address and then the customer both, yes, we can implement, right? That means what we can do, interface address extends customer we can do. So this is, for example, let's say permanent customer implements customer comma implements address. Is this possible? Questions for you folks. Is this possible?
Yes.
Correct. So
One question, sir. So we can make our functions as a default function and make it as a sample implementation, right, in an interface itself. Will that solve the problem?
But it will be available for all the classes, right? Irrespective of the implementation. Our problem is what? Don't have the unimplemented methods in the interface. Let's move the unimplemented methods to the other interfaces. Unimplemented meaning unused, what I mean to say. Don't keep unused methods in the interface. If there were such methods for the future purpose, make them into another interface.
Okay.
Yeah. Okay, so this is what the interface segregation principle, and then the last principle is what? dependency inversion principle. Dependency inversion. So dependency inversion principle. What is this dependency inversion principle is saying? High level modules should not depend on the low level modules, right? What is this actually? So we have the abstract classes or interfaces, which will talking about the abstractions. So abstractions should not depend on the details, that means the implementations. What does it mean? What does it mean? Dependency inversion. What does it mean? For example, we have a class that executes a method with one tool, like, when we say java space -jar test.jar, then only the command line runner, right? Command line runner run method will also be executed, isn't it? Because command line runner have a run method which is called automatically after exactly the Spring Boot application is started, right? So this is called what, high level class, we can say, high level module or class, we can say. And what we can do now, low level class. Low level class meaning, the tool, this java space -jar is there, na? The tool that is needed to execute the action. That means Java need to be set up to execute the java -jar, this test.jar. To do this, we require the Java need to be set up, right? This is the low level class. I mean low level requirement, a high level requirement, meaning low level dependency, high level dependency. Now, what is this is talking about? What is this is talking about? High level modules should not depend on the low level modules. Both should depend on the abstraction. So what means, this is the high level requirement, high level module, let's say a low level module, low level module. Now, high level module, low level module should not depends each other. Rather, high level module, and then the low level module, both should have to depend on some abstraction. That means what? We no need to set up the Java. Java should have to come automatically, where we can execute this high level method, which is nothing but the dependency inversion. That means whatever the dependency that we have, we are not taking care of it. Let the other are taking care of it. For example, if we can take the EC2 machine, right? EC2 machine is already coming up with the Java versions available. We just need to install them on that machine. That's it. No need to worry about, no need to go somewhere and then get the installations. Meaning, whatever the dependency we have, that we are inverting to the third party member. We are not taking the responsibility of installing the Java or something else. That is already available. We are just running our dependency, which is depending on that Java. So this is called dependency inversion. So that's all, folks, from the solid principles point of view. Then tomorrow we will discuss about the the other principles and then characteristics of the microservices. Any questions for me in these solid principles? Any questions? Okay. Okay, any questions? Okay, if no questions, then I'll stop my screen share and then see you tomorrow at the same time. Any questions? Okay, thank you.